I'm Vinod. I'm a product manager at Google.
And I'm Guillaume Laforge. I'm a developer advocate for Google Cloud, and I'm also a Java champion. And I'd be curious to know who's a Java developer in the audience? Yeah,
Yay!
that's awesome. You're in the right place today.
A quick housekeeping note. I know all of you are using the app here for the conference, so we have a dory for question and answer, so feel free to pour in your questions as the talk goes on, and we'll address them at the end. So let's get started. So here's a quick agenda for the talk. So we're going to give you a brief overview of serverless at Google Cloud, and then specifically get into the what's new in Java and serverless. And after that, provide a demo. We have an exciting demo over a broad range of products. And then conclude with serverless beyond compute for certain additional offerings beyond our compute spectrum. So to start off with, what is serverless in Google Cloud? So our definition of serverless in Google Cloud is to build and run software without provisioning, managing, or maintaining physical or virtual machines, completely easing the pain of the users. Just give us your code and we'll run it for you. Furthermore, to elaborate on that, we consider that to be an operating model, zero server management. We consider it to be completely secure and pay for only what you use in terms of a billing model. Additionally, we want a developer experience and a programming model focused around service-based management. So you build your own microservices that you deploy in the cloud. We want it to be event-driven. So you submit a cloud image to a GCS bucket, and you trigger a cloud function, or any other event, submit a pub sub message, or any other activity that you have to trigger sprinkles of compute of cloud in the cloud. Lastly, we want to be open with zero vendor lock-in. And these are the two paradigms around which we define serverless, an operating model and a programming model. And we have what we call a full stack serverless offering in Google Cloud, spread across 7 areas, a bunch of compute offerings, but over a broad other areas such as storage, DevOps, data analytics, messaging, ML and AI, and smart and chatbots. A lot of these technologies are decade-long of Google engineering experience exposed to you. For example, BigQuery is like a big engine that we have worked on for several years, and we expose that as a serverless offering for you. In this talk, we're going to jump deeper into some of the compute offerings, especially, and also the Java offerings in this space. So to start off with, we want to talk about cloud functions, which is in compute, source-based event-driven functions. A simple example would be like you submit an image to Google Cloud Storage and you want some work done on it, so you can trigger a bunch of APIs to do that work. After cloud functions, the next thing in the spectrum we talk about is App Engine. App Engine is our decades-long old serverless offering. If you want to build a simple web app in your favorite programming language with stateless serverless offerings, we consider App Engine as something for that. And then we have our latest offering, which is Cloud Run, which is serverless containers for fully managed HTTP request response, which can be run on a fully managed system within Google Cloud, as well as on Kubernetes Engine. So dig deeper into cloud functions specifically. As I mentioned before, we consider cloud functions as our event-driven serverless compute platform. What we vision it as triggering sprinkles of compute of cloud, which basically then help you build your applications of gluing together code to run your various services. For example, you have different cloud services that could even invoke cloud functions that invoke different APIs, the result of which is then processed by these services. As I said, upload an image to cloud storage, do some work using an ML API, the result of which could then be stored in Google Cloud Storage as well. It's a fully managed offering, it scales automatically, and it's pay per use. We consider it to be a streamlined development model where you write your function and deploy it with a single command. And it has integration for events with different GCP products, as well as HTTP. Classic use cases for cloud functions could be like webhooks. You have different clients that invoke a webhook, and then that could start triggering a HTTP function to process some work. You can invoke different APIs through a cloud function, such as the ML API and so on. And events. Events are very imperative. For example, a good use case for this could be is like if you had BigQuery and you had a lot of audit logs that you wanted to track, and you went through logging activities such as say Stackdriver, which fires events. You could then use functions to process those events and do some analytics on that. The next use case will be lightweight ETL. For example, like you upload certain data to cloud storage, and then you can trigger a cloud function to do some processing on that data, and then store the analysis in a data store. And lastly, IoT and edge devices. If you have different edge devices deployed across all over regions, like if you're an oil company or any other company, you can, those events could be fired and then into the cloud, maybe through a messaging system, and then you invoke a function to do some processing to store the results. So these broad range of use cases can be accommodated under cloud functions, or function as a service as we call it. Currently, cloud functions is offered in these runtimes. They're all GA. In these same runtimes, we have additional versions which are in beta and alpha. And today we are really excited to announce Java on cloud functions.
Woohoo! Thank you.
Thank you. The team's been working really hard for it. Many of the engineers are sitting right here. So we have been really excited to get this ready for you. And to go deep dive into cloud functions in general as a product, we would also recommend you go attend the Run Cloud Functions Everywhere talk. It's by my colleague Stuart Reichling. It's a very exciting talk, and I highly recommend it. Going on from cloud functions to App Engine. So as I mentioned before, App Engine is our 10-year-old serverless offering. It was one of the earliest serverless offerings. If you want to build your traditional web app on your favorite language, such as Node.js, Python, or Java, you can use App Engine along with frameworks such as X+, Flask, and Spring. The product has various advanced management features such as application versioning, traffic splitting, IP firewalls, logging, monitoring, and so on. We've come up with new runtimes, which are all GA, such as PHP, Go, Node.js. Further, we're really excited to have Java 11 on App Engine, as well as Ruby. Further on, moving down, I want to talk about the most recent offering, which is Cloud Run, which is serverless agility for containerized apps. We've talked about it a lot in Next recently, and I want to elaborate a little bit more about it. What this basically means is taking a container from production to deployment in seconds. Just give us a container in any language or any library, and with a single command, it gets immediately deployed in Google Cloud, and you have a URL in seconds. Further, we consider this to be a natively serverless offering. What this basically means is you don't, as I mentioned before, you don't have to manage any servers. Just focus on writing your code. It scales up very quickly. It scales down to 0, and you pay exactly for what you use, the life cycle of a request. And it's one experience where you want it. What this basically means is you have a unified developer experience on where you want to run your application. For example, like if you want to run it on a fully managed deployment within Google Cloud, you could. If you want to run it on GKE, Cloud Run works on Cloud Run on GKE, where you get additional control on your cluster. And if you don't want to run it on Google Cloud at all, this entire technology is based on what is called Knative, and you can run Knative on your on-prem systems on Kubernetes and run your containers there. By doing this, we want to make sure that you have the full spectrum of offerings across the cloud and on-prem systems, and with 0 vendor lock-in. So now what's the Java story for serverless? So we're excited to announce, as I mentioned, Java 8 on Google Cloud Functions. Furthermore, we have Java 11 on App Engine Standard. It's a great offering, and I highly recommend you to try it. And then we have Java on Cloud Run, where you can run your favorite frameworks such as Spring and so on our Cloud Run offering. Given this, we now look to try a demo. We have an exciting demo for Guillaume, and
Thank you.
We'll take it from there. Could you switch to the demo, please?
Thank you. So, Cloud Functions, App Engine, Cloud Run will demonstrate the 3 products. So here is the typical screen from the Cloud Console, and we have a couple of functions which are already deployed. And so when you create a function, what happens? So let's say hello next. What's new for you today, Java developers, it's the fact that we now have this line, Java 8 alpha, that you can see here, and it allows me to write my Java code here. So I have a Java file here, and I also have a pom.xml file, because when you do a source deployment of your Java functions, we're using Maven to build your Java code. But you can also do fat jar deployment as well. So here, if you have already precompiled and you're using, for example, a different build tool such as Gradle, you can do that without needing Maven. But here, when you do source deployments, we build transparently for you in Cloud Build, and we're using Maven for that. So let's have a look at, well, we can actually start with the pom.xml, this Maven build file. So notice that I'm specifying Java 8 for a compilation purpose, because I'm using Java 8. And I added this servlet dependency, because we're using the servlet dependency here. Perhaps I can put it there. It might be a bit bigger. It should be more readable. So this is a simple class, and we have our processing function here, which is called hello world. It takes a request parameter, HTTP servlet request, as well as a HTTP servlet response. Then from the response, I'm getting the writer, and I'm going to write on the output my little hello world message. So I've already deployed it earlier, and I can easily test it from there. Hop, testing, and then it's going to call my function and print hello world. Yes, hello world. But since it's about Java, but it's not just about Java, in the sense that on the Java ecosystem there are also alternative languages. So I wanted to show you the fact that we can also run with other Java-friendly languages. So I have another example. I can show you that, for example, in my Visual Studio Code. I'm using Groovy. I'm the Apache Groovy co-founder, so that's why I'm biased and I like this language on the JVM. So it's pretty simple. It's just a Groovy script with, similarly to what we had with Java 8. We just have the process method here, no need for class or anything surrounding this. And same thing, I'm getting the writer, and I'm writing on the output. And I just wanted to show you as well, so since we did the deployment earlier with the console, the web console, you can also deploy it from there with gcloud on the command line, with gcloud functions deploy, the name of my function. I specify that I want to use the Java 8 runtime, even if it's another language, that's okay. HTTP trigger, and the entry point, that's actually main, that's the name of my Groovy script, and process, the name of the method. And I'm doing a deployment from source, so I'm saying --source dot. And I can also do that for jar, so if I have a fat jar already precompiled, I can also deploy it from there. And then, just to prove that it works, I can show you testing, and it should print hello Groovy world in a few milliseconds. Yes, hello Groovy world. So we saw HTTP functions, but we also support background functions, such as a new file uploaded to cloud storage, and you want to be notified and have your functions being invoked when this is when a new file is stored, PubSub when you receive messages on a topic from PubSub, etc. And actually, I didn't mention that as I was using the default HTTP select box here, but you can also specify, okay, I want to create a PubSub method, and you can see, oh, this is still Node, sorry. And you have some of the samples here to help you get started. And to illustrate those background functions, I would like to highlight this demonstration here. If you go to the showcase on the exhibition floor, there's a Cloud Functions demo, which is running. That's called the Serverless Postcard. And it's a little application which allows you to select a picture, for example, this one. You can customize and give a little message there, hello attendees, and it's going to process my picture with all the runtimes that we have. So Node, Python, Go, and Java. And notice that Java is pretty fast, right? Same as fast as, it's actually the fastest, yes. So I'm not going to say anything. I don't want to, I mean, if there are non-Java developers, you know, the other runtimes are totally great. But my function was super fast in Java. And it was fast in Go as well. And then, so you can click on the View Code button to see what the code looks like. And there's a little sharing button which puts a message on Twitter and shares this picture. And I wanted to show you the this architecture diagram. So what do we have? That's an Angular application, which is also using Firebase with an Ajax call. It's going to call a first Java function, this HTTP function here. We pass the name of the file, the picture, the picture file name, and as well as the message. This function is going to post a little request on PubSub on a particular topic. And then this message, because those four functions here in Go, Python, Node, and Java are going to be woken up because there's new message coming up on a topic. So those functions here are PubSub functions, triggered functions. Then those functions will process the picture, you know, add the frame, type the message, etc. And once they are done, they are going to save the resulting picture in cloud storage. Since we stored something on cloud storage, there's going to be another asynchronous event notifying another Java function which will retrieve all the pictures and update some metadata in my Cloud Firestore database. And also because I'm using Firebase on the front end, I'm able to update the front end as soon as I gather all the URLs of the pictures that have been processed. So what I'd like to show you is one of the Java functions, the one doing the image processing, which is a PubSub function, and the one doing the cloud storage event handling. So let's have a look at the code here. So this is my image processor. I'm going to hide that to have a bit more space. So this function is going to receive a PubSub message. So that's my process method. The PubSub message, actually under the hood, we're using the JSON library, which does marshalling, unmarshalling of JSON to and from Java objects. And if you go at the very bottom, actually, there's my PubSub class here that's unmarshaled. And I'm interested in the data field because this data field contains my image request payload with the file name, message, etc. So I'm receiving that, sorry. I also have access to, it's an optional parameter. There's a context if I need some additional data about the event ID, timestamp, event type, resource, etc. I'm not using it in the function, but I wanted to show this context class. Then I'm just decoding the data from the PubSub message, and there I'm using JSON directly because I know that what's in the payload of the PubSub message is actually some JSON content, so I want to get an instance of my image request which contains the file name, etc. I'm doing a bit of cloud storage handling because I want to retrieve, where is it? Yeah, image download to. I want to retrieve the image from cloud storage. That's where I store all my pictures. And then there's a long part of the code, you don't have to look at it too closely, where I'm actually using Java 2D to do the image generation. And when I go towards the end, once I've drawn my picture, I'm going to write that and store that again in another bucket in cloud storage. So that's what I'm doing there, actually. Okay, so this new processed image is in cloud storage, so it's going to invoke asynchronously another function, which I call the watchdog, which is going to update Firestore with this new information. So similarly, I have a GCS event. That's actually myself who created and defined this class at the bottom. I just used the bucket and the name fields, but there are other additional attributes, but I'm just interested in those two. So I just create a simple class with those two fields. And then here, I'm going to use Firestore to specify, so I'm doing some regex stuff to retrieve the name of the runtime and things like that. And once I have that metadata, I'm going to put the information in Firestore. So I've got my document reference, and then I'm going to here set the data in Firestore. And then that's what is going later on to update the UI here with, so if I do another little test with some random message, that's once the data is stored in Firestore, it's updating the pictures down below. So that's about it for functions in Java. HTTP functions, background functions with cloud storage and PubSub. All right, so let's now have a look at App Engine. So I have prepared another little demo where you upload a picture, and it's going to be, well, it's somehow artistic in a way. So I'm redrawing the picture with some squares, circles, and letters. So here I'm going to take a picture that I have locally here. So I'm going to take a picture of one of our colleagues, Roberto, who was one of the architects behind Java EE, and also one of the key engineers working on App Engine Java. So it's a bit unfortunate that he's not there with us anymore because he passed away recently, but I wanted to show that we had him in our thoughts. And I'm going to use, as for the letters, I'm going to use his first name. I'm submitting that, and it's going to draw. So I'm uploading the picture, and then it takes a second or two to draw the picture. And here is an artistic vision of this original picture. So I'd like to show you how I implemented that with App Engine Java 11. So I'm going to switch to here. So what do you see here? First thing I'd like to highlight is that you're not limited to servlet-based web frameworks. You can use any web framework that you want to create your App Engine applications on the Java 11 runtime. So that's why I decided to use Micronaut. It's a super fast with super slow startup frameworks, which is pretty straightforward and pretty easy to use. So I have a controller here for which I actually inject my service class that's going to do the image manipulation. I have, so here I'm serving the static asset with the form. And here, more interestingly, that's the URL when the form that you saw earlier is going to post the picture and the message and the letters that I've chosen to this process endpoint through a multipart form. And either I'm going to return OK if everything goes fine, or server error. And here, this is the part where I'm actually calling my service, artist service, which is here. And so it's a singleton service that I injected earlier. And then I'm doing, again, some Java 2D. You're going to think I'm a fan of Java 2D. So I get the bytes of the picture, and I'm going to return the bytes of the processed image. And then, well, some Java 2D stuff, Java 2D, Java 2D. And then I'm outputting, I'm putting the bytes back. And that's what this service returns. So that's basically how it was implemented. But let me have a look at the app YAML file. So I mentioned that we don't have to use servlet-based frameworks. Here I'm using actually just a fat jar that I compiled here. So I'm using Gradle for the build, but it's irrelevant here. I created a fat jar of my application that I can deploy. And notice that I actually have full control of the entry point, meaning that I can, pass things like garbage collection parameters. I can pass any kind of parameter to customize the way I'm going to launch and invoke the Java, the Java command. So fat jars, not limited to servlet-based payloads and workloads, and full control on how the Java command is invoked. So really no limits anymore, thanks to this new Java 11 runtime. And my last demo, that's this one. So this time I decided to use Cloud Run. So it's a little Sudoku puzzle generator, so you can generate as many puzzles as you want. So I'm using the Google Cloud hexagons, the logos. I can define different levels. I want a hard puzzle, I want an easy puzzle, etc. And the thing is, I had there was a tool that I was interested in using called QQWing, that's the name of the project, which is a Sudoku generator and solver. But it's a binary application. So I don't necessarily have, I wanted somehow to be able to use that binary C++ application within the context of my Java application. First thing. Second thing, I wanted to experiment with new features of Java. The Java language, for example, Java 12 has added a new experimental feature, actually, which is the new switch expression, which are more streamlined compared to the old switch case. So let me show you what I did. So just because I thought that I could use yet another framework, and I should start from the bottom there, here. So there's lots of red in Visual Studio Code. That's because I'm using those new Java syntax constructs that are not supported yet in Visual Studio Code. So that's why there's lots of red underline. So here I'm using the Ratpack framework, which is also a very lightweight framework, not based on servlets, and which is using the Netty library. So I define my server. I say I'm listening on port 8080. I'm serving some static content, for example, for the pictures of the hexagons. And then I've got two routes. So I have one for displaying the pictures, the hexagons, and the other one, which is the one which generates the Sudokus. And I'm passing a path parameter, which is the level here. And what I wanted to do is to be able to use this Java 12 experimental switch expression notation. So notice that it's a little bit different compared to the old switch case statement. So you can specify different values like easy and cool on the same line, and you're using an arrow instead of the columns, and you don't have to use the break. So for that, I really needed to use Java 12. Of course, I could have used an if-else statement, but just because I can, I did it. So I have this switch statement, and I also wanted to show here that I'm using the process builder to invoke my Sudoku generator. So that's what I'm using. I'm doing here. I'm starting the process, and I'm going to retrieve the output of this C++ program. And let me show you what my build and my Docker container look like. So as you can see in my build, so I'm using Gradle for the build. As you can see, I specify that I want to use the Java 12 syntax level, but when I'm compiling my code, I'm also using this special Java compiler flag enable preview, which enables this new experimental syntax. What else? That's about it here. I'm also using the shadow plugin, which is which creates fat jars when you use Gradle for the build. And the Docker file. Let's have a look at the Docker file. So it's a multi-stage Docker build. I actually have the first step, which is about building my application and invoking the shadow jar command to create my fat jar. So this is this part building my app. But then here's the image I'm going to use and that I'm going to push on Cloud Run. So I needed, I needed my little binary file here for generating the Sudokus. And I'm retrieving from the first stage of my build, I'm retrieving the fat jar. And then what else? I'm exposing port 8080, and then I can specify the entry point as well and specify, okay, I'm launching a jar and I'm enabling this preview feature that should be available when I'm running my code. And then, so if you look at the very bottom, you can see how I built with Docker and then Docker run, so I can run that locally without a problem. And then I must have somewhere a Docker push command, well, somewhere in my history, it's too far. So I can very easily, again, push my own, whichever version of Java that I want to use in my application. Here I'm using Java 12, and I can use, of course, anything that can be put in the Docker container, basically, I can put that there. And then I have my service running here. My Sudoku generator service running in the Cloud Run Cloud Console. Yes, that's about it for the demos.
Yeah, thank you for the exciting demo, Guillaume.
Thank you.
As you all saw, we saw our Java offerings across Cloud Functions, App Engine, and Cloud Run with the live demo. So super exciting demo. Thank you very much.
Thank you. Thank you.
So switching back to the slides, as we move on with our talk, we want to talk about serverless beyond compute. And specifically, the thing that we wanted to talk about here was, compute is not just a vacuum. You need ancillary products to work with serverless offerings to build an end-to-end service. For example, let's say you want to run a cloud function, but you want to run it on a schedule, like every Friday morning or so on to do some work. Or you want to queue a bunch of tasks or a bunch of functions to be executed at a later point in time, a month later, a week later, or so on, or you want certain retry semantics, then you need some kind of queue to queue those works to various microservices. Or further, if you want to store your end results in a data store, you need a data store where you can store the result for, say, your ML work being processed from a cloud function. So given that, I'm going to talk to you about two specific products that could help in building these end-to-end applications. The first is Cloud Tasks. Cloud Tasks is a point-to-point queuing system for asynchronous tasks across microservices. It's a queuing product for reliable task offloading. It's a fully managed service. If you have any long-running async work, such as you have like a job that needs to be run to process an image, and the end result of the processing needs to be stored somewhere, you can queue it up in this particular product. It has really good rate limits and retry controls. In queuing systems, it's very important if you have a workflow of systems that you set the limit to the weakest link in the chain. Cloud Tasks really gives the end users a control to set these rate limits and retry semantics. So based on the guarantee needs of your system, you can tweak it accordingly. Further, it provides for flexible routing with HTTP auth, so you can hit your endpoints and services securely within Google Cloud as well as your on-prem systems. To know more about Cloud Tasks and its retry semantics, its rate limits, dynamic scheduling, and other features, we have a dedicated session for this called Cloud Tasks Point-to-Point Asynchronous Tasks Across Microservices tomorrow. We really appreciate it if you can come there, and it's an exciting product, and the teams work really hard for it. Moving on, as you're building these systems, we always need like a cron system. For example, if you're scheduling functions every Friday, you need something that you can set your schedules on. And at Google Cloud, we have a product called Cloud Scheduler. It's what we call the cron for the cloud. It's a reliable enterprise-grade cron scheduler that can reach different endpoints such as HTTP, pub sub, and App Engine targets. It's fully managed and pay for what you use. It supports the popular Unix cron syntax and has a delightful UI experience. So you can create your schedules from the UI as well as the CLI. Furthermore, you have a really good monitoring dashboard. So you can track the status of your jobs through the UI. and also take corrective action wherever necessary. This is something that is very common. We have seen a lot of customers use, cloud functions coupled with cloud scheduler on a recurring schedule. They really like the Unix cron syntax. So we highly recommend you trying this product out as well. Additionally, it offers security, so you can hit these different endpoints with security and authentication, both within your Google Cloud as well as your on-prem systems. To know more about Cloud Scheduler, like we have a session, serverless in real world, the customer stories from smart cities to retail analytics. It's by Brett McGovern, one of our developer advocates. And we have a 15-minute dedicated session from one of our customers who's using the product. So we highly recommend that you attend this session as well. So that's pretty much the summary of our talk. And in terms of next steps, we highly encourage you to try our Java offerings on Google Cloud. We also recommend you to sign up for the Cloud Functions on Java 8. Here's a QR code. If you have any questions, feel free to reach out to us anytime. Both our contacts are here. And we have another Java talk by one of our developer advocates, Ray Sang. We talked about a lot of serverless offerings here for Java. But if you want to run Java applications on Kubernetes and do a deep dive on that, he has a really good session on that, and it's really exciting as well. To summarize, we've spoken to you about various Java offerings across Cloud Functions, App Engine, as well as Cloud Run. And these are really interesting products, and giving you the option to pick and choose what you want based on your needs is something that we wanted to do. And we've demoed that as well with Guillaume here. So yeah, at this point, thank you very much for attending the talk.